Welcome back. This is the third part of Chapter 4. We're going to go ahead and scroll all the way down to the section. I believe it's 411. We need to start with. There we go. Oh, there you go. Okay. Validating user input. So when we're validating user input, we want to make sure that the data being entered in is in an acceptable format for us. And when I say acceptable format, I mean even just data that we can use. And we'll talk about that here in a moment. But one thing to understand is bad output will produce bad input. So when I said whether it's an acceptable piece of data, let's go ahead and talk about this last one first, where we're talking about some of the tests you can do. Divide by zero is a good example. Now, if you say to the customer, hey, you have to enter an integer, zero is a legitimate number. That is an integer. However, if it's going to be the divide by, then you're going to get divide by zero error. So this would be a good place to check for zeros. But you can check multiple things, and real quick, we'll talk about range and reasonableness, valid menu choice, and divide by zero. So range is pretty self-explanatory. Reasonableness is one example of reasonableness is, let's say we're asking for a random number 1 through 10. Well, if they give us 11, that's not going to be reasonableness. And so there's a good example. Kind of goes along with that valid menu choice. If we only have 4 options and they try to pick an option that's not there, then obviously we're going to have a problem with that. So here is a quick and simple program to kind of show you where we're going to do some validation. And the validation in this actual program is right here. This is a range test. So we're checking to see if the score is between the min score and that it's less than or equal to the max score. And if it's not, then we're going to tell the user, we're going to do a C out, kind of an error to them, and says, this is an invalid score. Run the program again and enter a value in the range of, and we even utilize our min score and max score variables here, which are constants in this application. We know that because they are all in uppercase, so that's a good giveaway. They're constants. And we can then hopefully get the user to run the application again and put in the right number within the right range. All right. So comparing characters and strings. It's pretty simple when it comes to comparing characters. And that is each letter has an ASCII code that represents it. So, for example, the uppercase letter A is 65 in the ASCII scale. If you ever want to do a quick Google, you can do Google for ASCII values, and it will show you all the numbers and what they mean in ASCII. Some are readable characters like A through Z. Some are not, like tabs. So you should take a look at that. It's neat little ASCII charts are pretty neat. They're easily to find out there. So one reason why we bring that up is when you're comparing 1 and 2 as ASCII values and not integers, in this case it would work because 1 is less than 2, because 1 actually stands for 49, where the value of 2 is 50. Where you're going to get into some problems is if you start comparing these as strings, like 10 and 1. I think you'd be surprised what your results are. You should give that a shot. Lowercase letters have a higher ASCII codes than uppercase letters, so believe it or not, lowercase a is comparably higher than a high uppercase Z. Here is a neat little application that goes over whether someone has entered in a digit, because they're comparing the value that's getting entered in, which is a char. They're saying, hey, The char is greater than or equal to 0, and again, now it's going to convert behind the scenes to the char's value, and it's less than or equal to 9, then we know we've entered a digit. However, if they enter a character that goes in between the uppercase A and the uppercase Z, we know that they've entered an uppercase, and so forth and so on. If it's something else, then we know it's not a digit. It could be anything from a special character to technically an enter. All right. Strings work the same way when you're using the actual, when we're comparing using these relational operators. So here we have these relational operators. When doing it this way, it's going to do the same thing. It's going to use their ASCII values to compare. So kind of take a look at this slide and kind of work through it a little bit to see how Mary and Mark, and whether they are greater than, less than, not equal to, so forth and so on. Here's a neat little program to compare to see if a part number is a certain part number, and if it is, then it gives the price. Be careful with this because we're using the double equal sign. The value that has been entered in for part number must use the same upper and lower cases as the part. So in this case, they're both upper cases, so we would expect that S and the A are uppercase. If whatever the user enters is lowercase, this is not equal. Keep that in mind. The conditional operator. Now, this is a great little thing that we use. Actually, to be honest with you, most of the time I see this get used, it's usually when it comes to return statements, whether something should be returned. Often you'll see, let me put my pen on here, you'll see the value return if X is greater than 0, then it's going to return, let's say, true or false. So there's a good example of where we might see one of these conditional operators. But you can use them all over the place. This is not the only place you can use them, but it oftentimes is one of the more regular places. What's important to understand is these three conditions. This one is the tested. This is what it's going to look like. This is, in a sense, the if statement. And this is while it's known as the second expression, if this is true, this is what's going to happen. And then this is sort of like the else, because if it's not true, then it's going to go there. So the value of a conditional expression is, and this is what we just talked about, it says the value of the second expression if the first expression is true. So if this is true, then we're going to go here. If it's false, then we're going to go here. Another way of saying the same thing. Parentheses may be needed if an expression due to the precedence of the conditional operators. I will tell you, I see a lot of developers, and I might even be one of them, that likes to put parentheses around stuff like this just to help it be a little bit more readable anyways. So if you get to where you're wanting to say x is greater than 0 or x is less than 10, you would have to put a parentheses around that to make sure that it understands that you want to keep this all grouped together. Where is it in this code? It's pretty simple. It's actually right here. So this application is asking them to put how many hours were they worked. They're going to enter a value in. It's a type of double. It's hours. And so it's saying, hey, if hours is less than the min hours, then go ahead and just put the min hours. Otherwise, capture the hours they put. And so a good reason why they might do this is they might say, hey, if if a person works under 40 hours, we're going to go ahead and pay them 40 hours. But if they work over 40 hours, then we need to pay them for whatever they work. So if the person comes along and says, hey, I worked 35 hours, but the min hours is 40, it's going to put that in there. It's going to compare that to here. And they're going to say, oh, no, it's less than. So go ahead and plug 40 hours into the number of hours variable. If the user were to say, I worked 48 hours, then here we'd have 48 is greater than, or assuming is less than 40. So this would be false, which means it's going to utilize and it's going to take whatever we put in the hours and put it back in the hours variable. All right. The switch statement. The switch statement is a very specific kind of type of if-else-if statement. And it does some pretty neat things that the if-else-if doesn't do. So you'll often see the switch when it comes to menus, when you're looking at very specific data that might be in kind of series. Let's kind of take a look at an example. This is a very crude kind of display of how it works. We're going to here look at some code. It'll make a little bit more sense. But this is the expression we're going to evaluate. So let's say we have a variable that is capturing the menu item you press on the keyboard. So let's say our expression is menu. It's going to say, okay, what character is stored in the menu? And then our expressions are going to be those, let's see here, those possible values. And then the statement is going to be what is run if, let's say, A would run this statement, B is going to run this statement, D is going to run this statement, so forth and so on. This default is not required, but highly recommended. This is one of those things, again, like the else of a if-else-if statement. It's that last bit of trying to catch something that may not have been caught previously. Oftentimes the default is where we're going to say, hey, you didn't pick anything from the actual menu, try again kind of piece. This program shows exactly what we just talked about. So here we have where we've given the user the choice of A, B, or C. We are asking the user to go ahead and enter that in. If it's A, we're going to do this piece. If it's B, we're going to do this piece. And C, we're going to do this piece. Now, A couple of things to kind of point out here is this break. Without this break, one of the unique things about switch is if you didn't have that break, it would actually allow the code to keep falling through all of the other cases. So without this break, so let's imagine I did not put the breaks. We're going to kind of cross them out here. The magic of pen doodling. If the user then said, okay, I want A, what would happen is it would actually come in here, do this cout. Because there's no break, it would continue to fall through. It would do this cout. No break, it would keep falling through and do that one as well. And because there's no break in C, it would also do the default. It would keep falling through. So the break stops that. Once it does A here, it's going to hit that break and then fall out of the switch. The expression must be an integer variable or an expression that evaluates to an integer variable. That's why we can use chars here, because behind the scenes it can turn into an integer variable without any real work. Behind A is an actual number. Behind B, same thing. We would not be able to use strings per se if they cannot translate into integer easily. Expression 1 through expression n must be consistent integer expression or literals and must be unique to the switch statement. Same thing here, because A, B, and C can translate to integers. That's why we can do it. But we could not have two case Bs. And then we are talked about the default is option, but recommended. When we use a switch, that expression is evaluated. The value of the expression is compared against all of the other pieces. So in this case, we were talking about how in this is the expression, and it compares it to all of these. Once it finds that expression, it will go until it either hits the end of the switch or hits a break, and then will automatically pop out. If no matching value is found, the program branches to the statement after the default. That's if you have a default. And we already talked about the break statement. It's used to exit a switch statement. If it's left out, the program continues to follow through. Here's an example of why you might do that, because you might have been thinking, well, why would I want to fall through different cases? So think of a TV. The higher the model, the more feature it has. But like most TVs, if you get the base model, it comes with, like in this case, a remote control. But the 200 model comes with both the remote control and stereo sound. And then the case 300 comes with picture-in-picture, stereo sound, and remote control. They all build on top of each other. So that's why in this one, when the user puts in what model number they have, if they put 100, it's going to skip these first two and go right to this 100, fall through, and hit that break. However, if they put 300, then it's going to output that one. It's not going to hit a break, so it's going to then also output that one. No break, hit that one, and then it hits the break, so it doesn't go into the default. Good example of why we would want to not break out of an actual case. This is the results of what this program would do if you enter the different values. Feel free to take a look at that. It's pretty self-explanatory. We've already talked about switch statements is a natural choice for menu-driven programs. The expression is going to be what the user's input is, and then each expression within a case would be either if you have a number for the menu items like 1 through 5, or if you have a char, A, B, C, D, E, F kind of thing. 4:15, more about blocks and scope. You're going to hear the word scope a lot in C++ and pretty much most other languages. Uh, Scope is pretty important. JavaScript, in fact, has tried to go out of its way to make scope less important. And then recently I was talking to a colleague, and I guess even JavaScript is getting a little bit back to putting scope back into its development. So, interesting enough, scope is just a sign of where variables can work and where they have scope within a block of code. Pretty simple. Most of the time, scope is between curly brackets. Now, you can have additional curly brackets, and scope will continue to fall through those brackets, but it will not go backwards. It does not go outwards. We'll talk about that as we get closer to it. So, when we talk about using variables, we want to talk about the idea of here's our bracket. Oftentimes, we're going to put our var here. Let me actually. And then this var can be used anywhere within this block of code. When it comes to defining variables, the most common two ways of doing it is either define all your variables at the very top of the block of code, or to define them very close to where they're going to be used. Sometimes organizations also will step in and give some thought. My particular firm has a coding standard that all variables should be defined at the top of the function at all costs. If possible. I guess there are times where it's not really feasible and we won't do it, but for the most part, we want our variables named at the beginning of the code. Here we have some inner block variable definition. Now, the interesting thing about this is years being declared out here can actually also be used in here, because this inner squigglies, this inner block, is inside of these squigglies. So variables can go from the outer scope to the inner scope and be used. However, if we made a variable in here, let's say we said Boolean I tried, we could not use I tried outside of this bracket. So you can go from outer to inner, but you cannot go from inner to outer. Once you come out of this squiggly, this variable is no longer available. Let me recap that one more time. You can go from an outer scope brackets to an inner scope, as long as the inner scope is within the outer scope. So because this is actually in this, it works. If this piece was somewhere else in some other function, it would not work. However, if a variable is declared in an inner scope, like in here, int x, you cannot use this outside of that scope. What this slide is talking about is that when variables are defined within inside of a block, they're known as local or block scope. One of the things we just talked about was you can use a variable out here inside of here. However, this one slide is actually going to show you where you can actually stop that from happening. And that is, if you want to, on your inner block, you can use and define a variable with the same name as in the outer block. here's the deal. When you do that, when you're in that inner block, it's going to use the inner block's version of that variable and not the outer definition. And and I love this because they kind of put it here, and this is so true. Don't do it. Not a good idea. So don't do this. Um, know it because you may have a quiz test on it, but unless you have a very, very, very good reason, I can only think of really one off the top of my head, and even then I'm kind of grasping at straws. This is just a bad idea and will more than likely drive somebody in your organization nuts at some point because they're not going to understand why that variable is doing things the way it's doing. Here is a quick example of how we have this number variable, but we also define another int number within this scope. And so this number is another variable named number. And so all of this is using this number, while this number is not going to be used inside this scope. It really just doesn't make sense. And again, I would recommend avoiding it at all costs unless you have a very specific reason. And even then, you should probably write a lot of code comment on why you did such a thing. So that way later, when everyone is really angry at you for doing that, you have a real good reason in your code to remind you of why you needed to do something so special. Okay, so that is all of Chapter 4. If you have any questions, please feel free to email me, and we'll go over some stuff. I am. That is all of the chapters, I believe, for this module, and so this will be it until next week. Thank you.